All right, so let's get started here. So for problems 1 through 4, we're going to find the degree, determine if the leading coefficient is positive or negative, find the end behavior, and all zeros and multiplicities, then make a sketch. Okay, so if we're looking to graph one of these, find all this information, we're going to want to start by, well, this one's already in factored form. So first we need to decide, is it in factored or standard form? So remember, factored form, if it has like all of these kind of parentheses, everything, we're multiplying each of these pieces together. So since this is in factored form, for our degree, we're going to need to add our exponents together. So our degree for this one is going to be 3 plus 2 plus 1. Remember, if it's not written there, there's a 1 on that factor. So 3 plus 2 is 5, plus 1 gives us 6. So we have degree 6. Our leading coefficient, so since we're going to look out in the front of this whole thing, and it's a positive 1 out here. And so our leading coefficient is positive. If there was a negative out in front of everything, this would be a negative leading coefficient. So this is positive leading coefficient, and our degree is even. So if we have an even degree and a positive leading coefficient, that tells us that we're going up, up. Or in other words, we're rising right and left, rise left and rise right, going up on either side. So that's our first 3 bullets here, the degree, leading coefficient, and the end behavior. Then to find the zeros, we're going to set each of these factors equal to 0. So our first factor, x cubed, we don't really need that exponent, we can just set the x equal to 0. Our next factor, so that's going to be one of our zeros. Our next 0, x plus 4 equal to 0, so we're looking at that next factor. Subtracting 4, we get the x equals negative 4. So that's our next 0. And then our third factor, x minus 5 equals 0. Adding 5, we get that x equals 5. So now we've set each of our factors equal to 0, and we found our 3 zeros. Our multiplicities are going to be the exponents that were on each of those factors. So we look back up to where the 0 came from, and whatever the multiplicity or whatever the exponent on that is, it's the multiplicity. So this x equals 0, that came from this one right here. So its multiplicity is 3, which is an odd number. So we're going to cross. Negative 4, that came from this x plus 4, so its multiplicity is 2, which is an even number. So we're going to bounce. And this x equals 5, that came from the x minus 5. So that multiplicity is 1, which is odd. So we're going to cross. Remember to write the actual number for the multiplicity, not just odd or even. Okay, and so now we're going to graph these points. We've got x equals 0, x equals negative 4, and x equals 5. Those are zeros, which are the same as x-intercepts, so they're always going to go along our x-axis. Then we use that end behavior on our outermost points, the one that's the furthest to the left, furthest to the right, to kind of show what's happening there. We're going up on the left. We're also going up, rising on the right. And then we use those bounce or cross to do everything in the middle. At negative 4, we're bouncing. I like to work my way left to right. So I'm starting with negative 4. We're going to be bouncing. So that means it's going to come down, touch the x-axis, and then bounce back up. We don't want to go down below the x-axis. That would be crossing through. We want to bounce right back up. And then at x equals 0, so that's the next point we're going to worry about. We're going to cross. So go up, come down, cross right through. Now we're below, and then at x equals 5, we're going to cross again. And we don't need to be too picky as long as we're getting those bounce and cross correct and the end behavior, then this is a good sketch. And that's that. So let's see another one. So let's go to problem number 3. So for problem number 3, we have f of x equals x cubed plus x squared minus 9x minus 9. So our first step is to, again, identify, is this in factored or standard form? This one is not factored yet, so this is going to be our standard form. So before we can really do a whole lot with it, we could identify the degree, leading coefficient, and end behavior. But we know for the zeros and everything, we're going to need to factor this. Maybe let's do the degree, leading coefficient, and end behavior first. So the degree, if we're in standard form, our degree is the highest exponent that we have on a variable. We wouldn't want to add up these exponents. We're only going to be adding exponents when it's in factored form. So since this is standard form, we just take that highest exponent. So this is degree 3. And our leading coefficient is whatever we have, again, out in front of the whole thing, in front of that term with the highest exponent. So again, this one is positive, just like number 1. And so our end behavior, since we have an odd degree and a positive leading coefficient, is going to be down, then up. Or in other words, we're going to fall left and rise right. All right, so now to do anything else, we're going to need to factor this. So let me rewrite it over here. So if we have y equals, or f of x equals, x cubed plus x squared minus 9x minus 9. We notice we have 4 terms here, so we're going to start by factoring by grouping. Group those first 2 terms together, group those second 2 terms together, and we'll be looking to get a GCF out of each group. So for that first group, our GCF is x squared. So we'll go ahead and pull that out in front, x squared. And then what we're left behind with is x plus 1. And then our GCF for this second group is a negative 9. So we'll go ahead and pull that out. And again, we'll be left with x plus 1. Now we've got that common binomial, that x plus 1. All right, y equals x plus 1. And then our leftover pieces get written together, x squared minus 9. And now we notice this x squared minus 9, we can factor that a bit more. X plus 1 times x squared minus 9, this is a difference of squares, so we can factor this as x plus 3, x minus 3. So that was a difference of squares. And now we have this completely factored. We know we have it completely factored when we don't have any exponents left inside of those parentheses. Okay. So now we'll find our zeros. To find our zeros, we're going to want to set each of these factors, each one of these factors equal to 0. So we'll have x plus 1 equals 0, x plus 3 equals 0, and x minus 3 equals 0. Subtracting 1 from both sides, we get x equals negative 1. Subtracting 3, we get x equals negative 3. And adding 3, we get x equals positive 3. So x equals negative 1, x equals negative 3, and x equals positive 3. The x equals negative 1 came from this x plus 1. There's no exponent written, so we assume a 1. It has a multiplicity of 1, which is odd, so we're going to cross. This x equals negative 3 came from the x plus 3, right? X plus 3. Again, no exponent written, so the multiplicity will be 1, which is odd. And so again, we'll cross. And then the last one, x equals 3, came from x minus 3, which again has no exponent written. We assume 1, multiplicity of 1. It's odd, so again, last one, we're going to cross. Cross for all 3 of these. So we'll have negative 3, negative 1, and positive 3. Those are going to be our 3 points that we want to graph on that x-axis. Fill in that end behavior. On the left side, we're falling left. So we want to do something like that. And on the right side, we're rising. So we want to go up from there on the right side. And now at each one of these points, we're going to cross. So at -3, we cross. So we're going to want to go up through that x-axis. At -1, we cross again. So we're going to want to come back down through that x-axis again at -1. And then at +3, we cross again. So we're going to want to come back up through at +3, cross one more time. And again, as long as you have what is happening here at the x-axis and that end behavior, then this sketch is good enough.